This presentation is about task 4.7, which focuses on organic pasta. The presentation is by Alce Nero and FederBioServizi. The objective of this work is increased transparency in quality-labeled supply chain of organic products through innovative methods. So the aim of the demonstrator is the identification of pasta pesticides fingerprint in order to prevent and detect possible organic pasta fraud. Here you can see the production chain that goes from farm to fork. Alce Nero has several durum wheat fields located in Italy, in the regions of Tuscany and Apulia. Once harvested, the wheat can be stored in third-party warehouse or go directly to the mill. The mill is a partner of Alce Nero and grinds the durum wheat into semolina. The semolina is then sent to the pasta factory, also a partner of Alce Nero. The pasta is then produced in Trentino and packaged. The final storage takes place in Bologna, in the Alce Nero warehouses. This slide focuses on the possible fraud risks that could arise. Mainly the sources of risk can be contamination in the field, with containers that previously housed conventional raw material, silos, means of transport, or human errors. In short, poor cleaning, drift effect, and human errors. Where do our data come from? They come from two steps. Step 1, IoT data and AI monitoring. The sensors were planted in an organic and conventional field in Italy. Durum wheat is cultivated in both areas. The AI system uses NDVI index to classify the field as organic or conventional. The NDVI is a vegetation index that evaluates the level of vigor of the crop. In other words, it is the greenness index. This index is expressed as a number. Step 2, evaluation and definition of pesticides profile. Laboratory tests. Now let's talk about the data obtained from IoT sensors. The sensors record the following data: soil temperature, soil humidity, electrical conductivity, nitrogen, phosphorus, potassium level in the field, the battery of the sensor itself. As you can see, on the left, there is the trend of nitrogen in relation to a conventional field and an organic one. On the right, there is the trend of soil humidity. In both cases, we can see that the trend of the organic data is different from the trend of the conventional data. Before starting with the NDVI index, we had to provide the software with the cadastral data of the fields we wanted to evaluate. The AI combines the data from the cadastry with the area of the fields actually cultivated. Only after collecting the real cultivated areas, the fields can be processed with NDVI index. The NDVI index expresses the results, as you can see from the photo with the yellow and purple color. Yellow indicates organic areas and purple indicates conventional areas. We need to increase the level of data acceptability. The data is very complex and requires as many measurements as possible. The precision of the analysis increases with the collection of more data each month. Now, we're only looking at the maps with the highest level of confidence. We need to populate the AI model with more data and for a longer period in order to increase its accuracy. We are performing some audits in person to check the result of the AI model with the real state of the crop in the field and collecting point of improvements of the AI data. We also decided to combine this data with analytical data. Let's see step 2 together. Laboratory analyses are used to define a pesticide profile. This work is divided into two parts, the bibliographical part and the analytical part. The bibliographical one is characterized by the study of production yields and as many documents as possible regarding organic fraud. On the other hand, from June 2024, we will begin to carry out multi-residual analysis on conventional pasta, semolina, soils to compare and validate NPK data from sensors. Here you can see a summary table. Thank you for your precious attention.